So I was saying that depolarization conceptually could be interpreted as the movement of positive charges in this direction. Therefore, repolarization could be interpreted as one of two things, right? Just conceptually. It could be the movement of negative charges in this direction to balance out the positives, or it could also be seen as movement of positive charges in the opposite direction, going this way, right? But the point is, something equal and opposite happens to balance um, the process so that you return to a neutral state, or whatever state you began. Okay, so depolarization goes one way and should result in a complex or a particular vector, whether positive or negative, and so repolarization should be an opposite vector. However, there are a few things that you have to take into consideration with the ECG. So even though, for example, in a particular lead, the ventricular depolarization vector is positive, you will find that more often than not, the repolarization vector, which is the T wave, is also positive, right? So what is the reason for this? All right. The pathophysiology of it is a little bit complicated. However, it is simply this. Even though under normal circumstances, if I have tissue depolarizing, the first part to depolarize, which would be point A, is usually the first point to repolarize as well. Right? So point A depolarizes first, and point B and point A repolarizes first, right? Fine. So I would expect something like this, then like that, right? But in cardiac tissue, because cardiac tissue, the anatomy of it, right? So let me draw a cross section of muscle. All right, and essentially, all right, depolarization occurs in this direction because all of those conducting tissue, so like the Purkinje and those stuff, it's subendocardial, right? So it goes from the endocardium to the epicardium. Okay, so it goes in that way. Okay, however, the arteries that supply the cardiac muscle are coming from the surface, so epicardial arteries, and they perforate and they go to the endocardium last, right? So the theory is, it is believed that the blood supply to the endocardium is less than to the epicardium, or rather there is relative ischemia to the endocardium compared to the epicardium. Remember, we said repolarization is an active process, right? So repolarization or polarization, to get something polarized, requires energy, which means it requires blood. So if something has a relatively less blood flow, one structure or one area has a relatively lower blood flow than another area, then that area is going to repolarize more slowly. That is the gist of the situation, right? So what you end up happening is, yes, depolarization occurs in this direction, But because of the relatively better blood flow to the surface, which is the epicardium, compared to the inner part, which is the endocardium, you will find that the epicardium recovers more quickly and ends up repolarizing first. So repolarization goes in the opposite direction. All right. So what do you end up with? A negative, negative, right? Because if depolarization is positive, then repolarization would be negative. But if this direction is positive and this direction is negative, then you get a negative, negative, which, basic mathematics ends up with a positive. So essentially, in many situations, you get a positive QRS and a positive T wave. All right, so that is the explanation that I have read. A lot of the sources that I've read have also said that this explanation does have some limitations. It's not a perfect explanation, but this is one of the main underlying causes or reasons that it's believed that both the depolarization and repolarization vector is the same is the same direction in most leads. Okay.